The seventh problem is v of x comma y is equal to e power x into x cos y minus y sin y. So I want to prove that dou square v by dou x square plus dou square v by dou y square is equal to 0. So I want to find the second derivative of v with respect to x partially, plus I want to find the second derivative of v with respect to y partially, and then I want to add both the answer. I should get 0. This is the thing I want to prove. So now v is equal to, just I can multiply with this e power x inside. So e power x x cos y minus e power x y sin y. I can differentiate with respect to x partially. So I want to take e power x as u, x cos y as v. So first I want to keep this first function as I want to differentiate the first function. And the differentiation of x is 1. I want to keep the first function as it is, and I want to do the differentiation of x cos y. The differentiation of x cos y is nothing but 1 into cos y. Because cos y is a constant, I want to keep the cos y as it is, and the differentiation of x is 1. Plus, I want to keep x cos y as it is, and the differentiation of e power x is e power x. Minus, here I have e power x into y into sin y. Differentiation of e power x is e power x y sin y. So this is a first derivative of v with respect to x partially. So now I can write e power x cos y plus e power x x cos y. Just I am rearranging this and I am writing minus e power x y sin y. So I want to do the differentiation of this term again with respect to x partially. So e power x cos y, the differentiation of e power x cos y, differentiation of e power x is e power x only. Cos y is constant, so I am keeping as it is. So here again e power x x cos y I have. So I want to take this function as u and this function as v, x cos y. First I want to keep this e power x as it is, and I want to do the differentiation for this term. So differentiation of x is 1. Cos y I can write as it is, plus x cos y I am keeping as it is. The differentiation of e power x is e power x. And then for this function, y sin y is a constant, I am keeping as it is. So the differentiation of e power x is e power x. So that e power x cos y means 2 e power x cos y plus x cos y minus e power x y sin y. So this is the differentiation of v with respect to x 2 times. So I'm going to keep this as first equation. Then I want to find the differentiation of v with respect to y partially. I want to do 2 times differentiation. This answer I want to find. So now, so dv by dy is equal to, dou v by dou y is equal to dou by dou y of this v, the function we are given, e power x x cos y minus e power x y sin y. So I want to do the differentiation with respect to y. I want to do the differentiation with respect to y. This x e power x is a constant, I am keeping as it is. The differentiation of cos y is minus sin y. Minus, so here e power x is a constant. So no need to differentiate this e power x. I am going to keep as it is. Here I have y sin x. So y must be taken as u and sin y should be taken as v. I want to apply the product rule. So y I want to keep as it is. The differentiation of sin y is cos y. Plus sin y I am keeping as it is. the differentiation of y with respect to y is 1. So now dou v by dou y is equal to minus, I am taking before x. So minus x e power x sin y minus, just I am giving multiplication with each and every term with e power x, minus e power x y cos y minus e power x sin y. So again I want to differentiate because I need the second derivative. So that again I want to differentiate. So directly I am doing. So minus x e power x, the differentiation of sin y is cos y. Again e power x is I have as a constant, y cos y I have. So I want to keep the first function as it is. I want to do the differentiation cos y. So that is minus sin y, plus I want to keep cos y as it is. I want to do the differentiation y. So that is 1 minus e power x is a constant. The differentiation of sin y with respect to y is cos y. So I want to rearrange this. Minus x e power x cos y plus minus into minus plus e power x y sin y minus e power x cos y minus e power x cos y. So minus e power x cos y and minus e power x cos y means minus 2 e power x cos y. So the first term as it is I am writing, the second term as it is I am writing. So this will be the second equation. If I add first equation and second equation, first equation all the terms I have written, 2 e power x cos y, 2 e power x x cos y minus e power x y sin y. The second term I am written as it is, minus x e power x cos y plus e power x y sin y minus 2 e power x cos y. So one term is positive and one term is negative. So just we can cancel everything. I am getting the answer as 0. Dou square v by dou x square plus dou square v by dou y square is equal to 0. This equation, this special equation is known as Laplace equation. That is the second derivative of a function with respect to x and the second derivative of the function with respect to y. If I am adding both the thing, if you are getting 0 means this special equation is known as Laplace equation.